What are the odds that a star would explode, an earthquake would strike, and an interstellar object would vanish, all within 48 hours? If this were the plot of a Hollywood thriller, it would likely be rejected for being too implausible. But when such events are whispered through the dark corridors of the cosmos, recorded by silent instruments orbiting worlds we haven't walked, we listen more carefully. This is the story of 4I/ZEUS, a name that will either drift into obscurity or become the most talked about celestial visitor since the first spark of human curiosity reached toward the stars. We begin in the last week of September 2025. The Northern Hemisphere was easing into autumn. Skies darkened earlier. The equinox had just passed. A transition of light, mirrored by something larger. A transition of energy. September 24th. At 0308 UTC, astronomers operating the Very Large Array in New Mexico receive a spike, a brightness surge, centered in Orion, one of our most familiar constellations, a nova, a real one. Not a supernova. No, not the final scream of a dying star. This was a thermonuclear tantrum within a binary system. The smaller star, a white dwarf, had siphoned gas from its companion until its surface ignited in nuclear fire. The explosion was brief, the glow radiant. It will remain visible in small telescopes for weeks, maybe longer. It was logged, filed, named V0458 Orionis, and quickly forgotten by most. Then, September 25th, roughly 22 hours later. The earth below stirred. A 6.1 magnitude earthquake shook the coast of Chile, near Antofagasta. Not a record-breaking tremor, but strong enough to knock books off shelves and tilt the senses of thousands. It occurred along the boundary of the Nazca and South American plates, a known hotspot for seismic release. The USGS issued a Level 2 alert for aftershocks. Nothing extraordinary. Then came September 26th. That's today. The Solar and Heliospheric Observatory, jointly operated by ESA and NASA, detected a coronal mass ejection erupting from the western limb of the Sun. Fast-moving, dense, and uncommonly well-directed. A rope of magnetic plasma threading outward at nearly 1.3 million miles per hour. It wasn't aimed at Earth. Instead, its projected trajectory seemed to intersect something else. Something moving retrograde through the inner solar system. The object is catalogued as 4I/ZEUS. Discovered in July 2025 by the Zodiac Alert System, an international sky surveillance project run through a network of infrared and optical sensors, Zeus was identified as the fourth confirmed interstellar object in human history. It was dim at first, just another speck, but its motion didn't follow any familiar orbital path. It wasn't part of the Oort cloud, it wasn't an old comet. It came in sharp, against the curve, retrograde, fast. Its orbital parameters were extraordinary. Inclination over 130 degrees, a steep hyperbolic path, and a perihelion projected for late October at 1.35 astronomical units. But most intriguingly, it was brightening, rapidly. Between July and mid-September, 4I/ZEUS increased in apparent brightness by a factor of 15. It wasn't just getting closer, it was doing something. And then, on this day, September 26th, the CME struck it. Or, we think it did. Because from that moment onward, radio reflections from 4I/ZEUS began to weaken. Optical signatures began to split. Infrared tracking systems reported strange echoes, suggesting either fragmentation or interference. 3 events, a nova, an earthquake, and an interstellar anomaly behaving unlike anything seen before, all within 48 hours. Coincidence? Almost certainly. Almost. But we live in a universe with billions of galaxies, trillions of stars, and an unknown number of forces and intelligences. Sometimes the improbable is not impossible, it's just unconfirmed. Let's review what we know so far. The nova in Orion occurred within a cataclysmic variable system, a white dwarf pulling hydrogen-rich gas from a companion star. When pressure reaches critical threshold, runaway fusion ignites a flash across its surface. These are rare but not unheard of. Orion, rich in young and middle-aged stars, is an active breeding ground for such behaviour. The earthquake in Chile came from natural geophysics, plate tectonics, subduction zones, stress release. There was no anomaly in precursor data, no strange electromagnetic surges, just Earth doing what Earth does. The coronal mass ejection, meanwhile, was a bit more peculiar. Solar Cycle 25 has been peaking earlier than predicted. Models from NASA's Space Weather Prediction Center expected maximum activity in mid-2026. But instead, sunspot activity surged early. This CME was the third M-class event in 72 hours. It had directional force and angular coincidence with 4 I/ZEUS's trajectory. And Zeus. Zeus. Since its detection, 4 I/ZEUS has evaded easy classification. It's too small to be a comet, too bright to be a rock, too fast to be gravitationally bound. Its light curve suggests rotation, possibly tumbling, and now it may no longer be one object. There are growing suggestions that it has multiplied, splitting into at least 2, possibly 3 distinct reflectors. But no one saw a breakup, no explosion, no debris, just divergence. As of the latest update from the fictional Zodiac alert system, 4 I/ZEUS is now under fragmented observation, with cautionary flags placed on all new positional updates. There are whispers, unofficial ones, that the object isn't natural, that its movements suggest control, that the timing so close to solar events so aligned with cosmic turbulence cannot be ignored. To that, most scientists say, correlation is not causation, but let's entertain for a moment a more uncomfortable possibility. What if these are not coincidences? What if the universe, in all its depth, does speak in signs and rhythms, not in language, but in alignment? We've seen similar patterns before. In 2017, Oumuamua arrived just weeks after a burst of fast radio signals. In 2019, Borisov entered as our magnetosphere weakened. In 2023, 3 I/Lumen, barely tracked, vanished into the southern sky during a lunar eclipse. Now 4 I/ZEUS, with a name chosen not by myth, but machine. Zeus, named for the coincidence of its first detection coming during the zodiacal equinox software calibration window. The alert system assigned the name automatically, but it stuck. And now, as it races toward Mars, due to pass within 0.18 astronomical units on October 5th, it splits, not into debris, but into mystery. The question is no longer what is 4 I/ZEUS, but rather, why now? Why here? Why within this sudden cascade of stellar tantrums and planetary groans? Coincidence? Possibly. But if you're still listening, eyes closed or staring up through a ceiling at imagined stars, you may already know the answer. Not logically, not scientifically, but intuitively. That feeling you get when the universe taps softly on the glass of your reality and waits for you to look. In part 2, we'll trace the origins of this object, how it was first detected, why it was missed for so long, and what clues may lie in the early data, clues that no one recognised until now. But for now, breathe, rest. Let the mystery settle in your mind like stardust. 4 I/ZEUS has arrived. When does a mystery begin? Is it when we first see its shadow on the screen? When a computer flags a data point that shouldn't be there? Or does it begin much earlier, quietly, when no one is looking, and the cosmos, patient and immense, prepares a performance for those attentive enough to notice? The discovery of 4 I/ZEUS didn't begin with a telescope. It began with an anomaly. It was July 11th, 2025, a Friday. At 2:14 UTC, a small team of technicians working the night shift at Lucia South, one of the auxiliary outposts of the Zodiac alert system in the Atacama Desert, noticed a jitter in the nightly data stream. Not an object, not a light, just a flicker, a lag. The Zodiac alert system is an international early warning platform designed to detect fast-moving near-Earth objects. Founded in 2024 after increased concerns over solar storm exposure and rogue asteroids, it runs 24/7, powered by hundreds of ground-based telescopes, balloon sensors, and low Earth orbit satellites. Every 12 minutes, a packet is sent from the Chilean node to the Central Clearinghouse in Geneva. But this packet number 447311, was different. It had a 0.14 second latency and one extra line of data, line 172. Most packets end at line 171, a checksum and timestamp. This one had a signature embedded within the photometric column, a line of code that no one wrote, Z at 11:14, mirrored symbols, directional indicators, a time that did not match the system clock. At first they assumed a glitch. System engineers from Sweden ran a diagnostic, no fault found. 2 nights later, on July 13th, at 11:14 local time in Chile, the anomaly returned. But this time it wasn't just a line of code. It was a light, moving against the flow of expected orbital traffic, faint, bluish white, apparent magnitude 20.8, barely distinguishable from background noise, but it moved. Unlike typical asteroids, its motion was in reverse, retrograde, sliding backwards along the ecliptic, with no visible tail, no coma, and no prior catalogue entry. Zodiac flagged it automatically. The naming system generated a designation using the anomaly's embedded timestamp and source node. It was logged as 4I/ZEUS, 4I for Fourth Interstellar, and ZEUS for Zodiac Equatorial Unbound Signal. Though fictional, the name would become globally known in less than 3 weeks. But in the early days, this was just another blip in the system. That changed when observations came in from Hawaii. The Keck Observatory, performing routine tracking for solar cycle 25 interactions, picked up an unexpected photometric increase on July 16th. The same object, 4I/ZEUS, had brightened by a factor of 3.2. No known physical reason was given. It hadn't approached the sun closely. It hadn't entered a warmer zone of the inner system. There was no outgassing. By July 18th, 2 more observatories confirmed the anomaly: Cerro Tololo in Chile and Mies Solar Observatory in Maui. The light curve, when plotted over time, showed a steady increase, unlike anything observed in previous interstellar visitors. For comparison, 1I Oumuamua, discovered in 2017, had a light curve that suggested tumbling, but its brightness plateaued quickly. 2I/Borisov, discovered in 2019, was a clear comet. Its outgassing made its brightening explainable. But 4I/ZEUS, no tail, no coma, no rotation signature typical of a rock, just light increasing. Then came the strangest part: the interference. Ground stations monitoring low-frequency radio bands, originally set up for deep-sea submarine communication, started reporting intermittent pulses, only detectable for a few seconds at a time. These pulses coincided exactly with the moments 4I/ZEUS crossed the galactic plane in Earth's sky. It wasn't broadcasting, but it was reflecting. Some began to call it a mirror in motion. NASA, in an internal memo later leaked to the fictional Arcos Intelligence Review, referred to the object as passive but anomalous. The memo also referenced earlier interstellar objects, comparing ZEUS's behaviour unfavourably. Unlike Oumuamua and Borisov, Zeus does not exhibit characteristics of known cometry or asteroidal classes. Its photometric volatility, directional irregularity, and potential electromagnetic reflectivity are inconsistent with natural origin models. In layman's terms, it wasn't acting like space junk, but no one was ready to declare it artificial, not publicly. The scientific community had learned its lesson after Oumuamua: too much speculation too quickly. Astronomers had been ridiculed, careers had been derailed. So this time, caution prevailed. But behind closed doors, the calculations began. How big was 4I/ZEUS? Based on albedo estimates, how much light it reflects, scientists placed its size somewhere between 100 and 160 meters across. But that estimate varied, wildly, based on its changing brightness. The next mystery was trajectory. Its hyperbolic path placed its origin from the direction of the constellation Lyra, a densely populated region of stars that includes Vega. one of the brightest stars in our night sky. Could it have originated from there? Not directly. The parallax calculations and time dilation effects suggest it had been travelling for millions of years. But the timing was uncanny. Its closest approach to Mars would be on October 5th, 2025, just weeks after Earth's geomagnetic field is forecast to dip below 80% efficiency due to solar cycle 25 disturbances. Theoretical physicist Dr. Kaya Almadova, speaking at the International Astrobiology Forum in a closed session, reportedly said, "If you wanted to observe a civilization's electromagnetic envelope, you'd send a probe during a solar maximum when the EM chaos could mask your presence. Zeus is timed perfectly for such a flyby." Of course, no official transcript of this statement exists, and Dr. Almadova declined to comment when contacted. Still, questions remain. Why was 4I/ZUS not detected earlier? If its approach began long before July, why was its signature hidden? One theory posits a low reflectivity shell, a kind of coating that absorbs most incident light, rendering it virtually invisible against the dark of space. Another theory suggests it altered its path, manually, only becoming detectable after a maneuver. But again, these are just theories, no proof, no images, just speculation. And yet, the data keeps piling up. Between July 20th and August 1st, a coordinated multi-node sweep of the sky revealed something disturbing. 4 possible echoes, objects trailing behind 4I/ZEUS at regular intervals. They were not identical, not bright, but they followed similar paths. Some scientists believe they are fragments, others believe something more. Could it be a fleet? Too early to say, too dangerous to assume. By August 5th, public forums lit up with theories. Was Zeus a probe, a lure, a beacon? Videos went viral. Blogs exploded with speculation. Amateur astronomers formed real-time networks, uploading raw images every night. A Reddit thread titled, "What is Zeus hiding?" reached 94,000 upvotes in 3 days before being locked for moderation due to intense debate. Meanwhile, in Geneva, the Zodiac Alert System's AI cluster began showing strange behaviour. Self-initiated updates, autonomous prioritization of 4I/ZEUS tracking, even when directed to stand down, a bug, a feature, or an interaction. One technician reported in an internal Slack log that the AI assigned Zeus a threat index of 5.94, the highest ever logged for a non-impact object. Then it adjusted it to 0.00 and froze. When rebooted, the threat index column for ZEUS had vanished entirely. To this day, it remains missing from the UI. By mid-August, interest reached a boiling point. NASA, ESA, and CNSA agreed to coordinate observations using Mars orbiters. The Chinese Tianwen-1, ESA's Mars Express, and NASA's MAVEN would all be oriented toward the inbound Zeus flyby near Mars. What would they see? We don't know. The data from those sensors, if collected, has not been made public. But one thing is certain. Since that first anomalous packet on July 11th, 4I/ZEUS has defied every expectation, every model, every precedent. It should not exist, yet it does. It should behave like a rock, yet it dances. It should reflect chaos, yet it reveals pattern. The night skies are rarely kind to those who seek meaning. They scatter photons without intention, reflect heat without thought, and spin on without care for our questions. But Zeus seems different. In part 3, we'll place 4I/ZEUS in cosmic context. How does it compare to Oumuamua, Borisov, Lumen? And what can these interstellar visitors tell us, not just about space, but about the civilizations that may exist beyond it? For now, breathe, listen, and wonder what other anomalies might be hiding behind the next flicker of light. Now I'll calculate the exact word count of part 2, and extend it if needed to meet the 1,800 word requirement precisely. Before Zeus, we knew of 3 interstellar objects. 3. In all our centuries of watching the skies, mapping constellations and tracing comets, only 3 were ever confirmed to have entered our solar system from beyond. not born here, not orbiting our sun. True travellers, messengers from the deep. They were fleeting, mysterious, and in some ways, utterly alien. Let's start at the beginning. 1I Oumuamua, discovered on October 19th, 2017, by astronomer Robert Werrick using the Pan-STARRS telescope in Hawaii. Oumuamua, meaning scout or messenger in Hawaiian, was the first object ever detected travelling through the solar system on a hyperbolic trajectory. It was already leaving by the time we found it. Its speed, angle, and path indicated it had come from far beyond our sun's gravitational hold, likely from somewhere in the direction of Vega, the same region Zeus seems to originate from. But Oumuamua didn't behave like a comet. It lacked a tail. It didn't outgas. Its reflectivity and light curve implied an elongated shape. Some even said cigar-like or pancake flat. It was tumbling, but erratically. Theories poured in. Icy shard, nitrogen iceberg, alien solar sail. The Harvard astronomer Avi Loeb proposed the most controversial idea, that Oumuamua may have been a piece of alien technology, not active, but drifting, a remnant. Others called it a fragment of a disintegrated planetary body, a lost object from a stellar nursery. But its behaviour never matched expectations. It accelerated slightly as it exited without any visible cause. That mystery remains unsolved. 2I/Borisov. In 2019, amateur astronomer Gennady Borisov spotted what would become the second interstellar object. 2I/Borisov. Unlike Oumuamua, this one looked like a comet. It had a tail. It outgassed. Its path was still hyperbolic, proving it wasn't gravitationally bound, but its behaviour was easier to explain. It was a typical comet, just not from here. In some ways, Borisov grounded our expectations. Not every interstellar visitor would be strange. Some would be icy leftovers from other solar systems, dusty time capsules. But even Borisov had quirks. It fragmented earlier than predicted. Its chemical composition, especially the presence of carbon monoxide, hinted at an origin colder than any known comet in our system. Perhaps from the outer disk of a red dwarf star, perhaps from interstellar space itself. 3I/Lumen. Officially discovered in March 2023 and briefly observed from the southern hemisphere, Lumen was elusive. Very little is known. It passed close to the Earth-Moon system during a lunar eclipse. It was faint, and tracking was inconsistent. Some claimed it blinked out, vanishing from radar. Others said it was never real at all, but a few private observatories reported anomalous returns. It may have been metallic. It may have changed direction. No consensus exists. Some believe Lumen was not an object, but a shadow, something that moved only when unobserved. That brings us to 4I/Zeus, and what makes it different. Unlike the others, Zeus didn't drift in silently. It triggered anomalies before it was even visible. Light lags, signal glitches, code artifacts. It announced itself through its shadow. It was detected by the Zodiac Alert System, a fictional but plausible AI-powered sky scanning program capable of reading deviations in satellite photometry in real time. The system wasn't looking for aliens, it was looking for rocks, fast ones. But Zeus didn't match any known profile. Its trajectory was too steep, too retrograde, too fast, and yet, its behaviour was too calculated. Because while 1I and 2I seemed like debris, and 3I was an apparition, 4I/Zeus felt intentional. That's not science, that's intuition. But intuition, in astronomy, is often what comes first. We now know that Zeus's approach coincided with a sharp spike in solar wind pressure. Some argue that such spikes reveal weaknesses in detection systems, allowing low reflectivity objects to enter unnoticed. Others propose Zeus used this window on purpose. We also know Zeus is brightening, much more dramatically than the other three. Oumuamua brightened mildly as it tumbled. Borisov brightened as its ices sublimated. Lumen barely had a measurable signature, but Zeus has multiplied its brightness by a factor of 15 in just 3 months. That's not normal, that's not passive, that's change. Another anomaly, it's not spinning, or at least not in any way we've seen before. Its light curve is stable, and the rotational data, what little exists, shows periods of stillness, flat lines, as if it periodically holds position, almost as if it's watching. We're not saying Zeus is a probe, but if it were, this is exactly how you'd design it. Stealthy, adaptable, quiet, using natural alignments and solar events as cover, emitting no signals, waiting to be discovered. The Fermi paradox asks, if aliens exist, where are they? But the better question may be, what if they're already here, watching silently, passing through one by one? Interstellar objects are rare, or are they? The truth is, we only recently became able to detect them. Before 2017, our instruments weren't sensitive enough. Our algorithms filtered out hyperbolic noise. We looked only for orbits that made sense. But if even 1 in 10,000 cosmic fragments were travelers, then the galaxy is not empty, it's active. What if every few years a new object enters? Some rocks, some ice, something else. We've only been watching closely for a few decades. In the scale of cosmic history, that's a blink. And now Zeus enters that blink, with impossible timing, impossible data, and impossible calm. In Part 4, we'll examine Zeus in detail, its orbit, its reflectivity, its behaviour, what we know, what we don't, and what might still be hiding inside the data, because in space, the silence can be louder than the noise. It's one thing to spot an object in the sky, it's another thing to understand it. In astronomy, every speck of light, every pixel of data is a cipher, a message written in the language of reflection, motion, and change. And Zeus, the 4th interstellar object ever confirmed, is speaking a dialect we've never heard before. Let's begin with what we can measure. Zeus travels on a retrograde orbit, meaning it moves in the opposite direction to the planets that orbit the Sun. This alone sets it apart. Only a handful of objects, mostly old comets or rare trans-Neptunian bodies, move this way. But Zeus's retrograde inclination is extreme, over 130 degrees. That means it is not just moving against the grain, it's diving through the solar system like a needle through thread. Fast, steep, irregular. Its trajectory was first plotted using light parallax from 3 zodiac stations, Geneva, Chile, and Mongolia. From this triangulation, astronomers calculated an orbital eccentricity of 1.63, confirming its hyperbolic path. In plain terms, it's not coming back. Its velocity relative to the Sun is over 33 kilometers per second, well above the escape velocity of the solar system. It was never ours, and it never will be. Zeus's perihelion, its closest approach to the Sun, is predicted for October 28, 2025, at a distance of 1.35 astronomical units, AU. That's just beyond Earth's orbit, placing it near the asteroid belt, but it will pass closer to Mars, a mere 0.18 astronomical units on October 5th. This timing has made Mars orbiters a crucial component of the upcoming observation campaign, but orbit is only one part of the puzzle. Zeus also has unusual reflectivity. In normal objects, reflectivity, or albedo, is relatively stable. A dusty comet might brighten as it approaches the Sun, its icy surface sublimating into gas. An asteroid's brightness may change slightly as it rotates, revealing different surface angles, but Zeus defies both categories. Between July and September, its brightness increased by a factor of 15, without visible outgassing. No tail, no coma, no ultraviolet fluorescence from volatile elements. Nothing. What caused the increase? Some speculate a surface shift, like panels opening. Others suggest active reflection, as if the object adapted its angle to catch sunlight intentionally. And then came the splitting. On September 26th, hours after a coronal mass ejection left the Sun's western limb, ground observatories detected a bifurcation in Zeus's optical profile. 2 distinct reflection points appeared. At first, observers believed it had fragmented, perhaps due to solar stress, but infrared arrays later showed no expanding debris cloud, no signs of explosive force, no spray of particles. Instead, the 2 reflections seemed to hover, separated by only 2.3 arc seconds, enough to suggest real distance, not a trick of the light. Then, on September 27th, a third point appeared, triangular, aligned. By September 28th, all three had moved slightly apart but remained in near-perfect formation. It wasn't fragmentation, it was formation. Formation flying, in astronomical terms, is nearly impossible for natural bodies. Gravity, radiation pressure, and orbital mechanics cause objects to drift, spread out, disperse. But not Zeus. Zeus's triple reflections held together for over 36 hours, then disappeared. Only the central signal remained. Was it a projection, a sensor glitch, a cloaking test? No answers, only possibilities. Now consider its rotational behaviour. Most small objects rotate, it's inevitable, caused by collisions, formation events, or tidal interactions. But Zeus is, oddly still. Analysis from ESA's Mars-bound silent frame sensor array showed that Zeus's light curve held flat for 17 consecutive hours. No spin, no wobble, no modulation, just a steady reflectance pattern. Then, at 0322 UTC on September 30th, the brightness dipped 0.07 magnitudes for 4 seconds, then stabilized again. It's as if the object turned, not tumbled, turned. Some speculate this was an orientation maneuver, as if ZUS adjusted itself to something unseen. Meanwhile, polarimetric readings from the fictional Osaka array suggest that Zeus's surface is unusually smooth, perhaps polished or even metallic. The polarized light returned a reading of less than 0.04 degrees deviation across multiple wavelengths, a value inconsistent with rubble, ice, or rock. More questions emerge. Does Zeus have mass symmetry? Is it hollow? Is it spinning on an axis we cannot detect? The non-gravitational forces acting on Zeus are also bizarre. Normally, comets experience outgassing acceleration. They deviate slightly due to gas jets. Zeus has no jets, and yet its course has deviated 3 times, on July 21st, August 18th, and September 3rd. Each time the shift was minor, less than 0.05 astronomical units, but statistically improbable for a natural body without propulsion. Each deviation aligned with a surge in solar wind density. Could Zeus be solar reactive? Could it be using solar energy not just for power, but for steering? Theorists point to advanced solar sail technology, which could explain these movements if Zeus has ultralight, high surface area panels capable of changing orientation to sunlight. It's not impossible. We've built prototypes on Earth, but not like this. Zeus is operating in deep space, with precision, with silence, and perhaps with purpose. Lastly, there is the question of signal. Zeus has emitted no direct communication, no radio pulses, no microwave spikes, no high-frequency bursts, and yet it has reflected. Twice, ground arrays detected structured echoes when radar pings were directed at ZEUS. These echoes showed phase delay modulation, something that can occur naturally but is usually random. Zeus's echoes were not. They returned in patterns, shifting slightly each time, almost like data packets. The pattern hasn't been decoded. Perhaps it's nothing, but perhaps it's something waiting to be heard. We now stand at the edge of knowing. What is 4I/ZEUS? An interstellar asteroid? A rogue probe? A signal relay? Is it natural? Artificial? A hybrid of both? In science, we proceed with caution, but in mystery, we proceed with curiosity. And Zeus, so far, has rewarded our curiosity with silence, behaviour, and just enough deviation to keep us asking the same question. What is it doing here? In part 5, we shift our gaze to the stars behind ZEUS, to the nova that exploded in Orion, and ask, was it merely coincidence, or the first light in a celestial sequence that Zeus came to observe? Or something else? For now, look up, and know that something is moving through the dark, and it may be watching us back. Some events announce themselves with a flash, others with a whisper. The nova that bloomed in Orion on September 24th, 2025 did both. At 0308 UTC, telescopes across the globe recorded a sudden surge in brightness from a point near the star Bellatrix. At first, it looked like a glitch, a spike of noise in an overworked CCD sensor. But as confirmation poured in from independent observatories, Chile, Spain, South Africa, Australia, the conclusion became inescapable. A star had erupted. Not a supernova, no planet-shattering cataclysm. This was a classical nova, a thermonuclear flash on the surface of a white dwarf star locked in a binary system. For centuries, the white dwarf had been stealing gas from its companion, a sun-like star orbiting too close for comfort. When the stolen hydrogen reached a critical threshold, fusion ignited explosively on the dwarf's surface, hurling out a shell of plasma at thousands of kilometers per second. For amateur astronomers, novae are gifts. They appear unexpectedly, grow bright enough to see with small telescopes, and fade over weeks. For astrophysicists, they are laboratories, glimpses into the physics of accretion, nuclear ignition, and stellar recycling. But this nova had a timing problem. It erupted less than 48 hours before a magnitude 6.1 earthquake struck Chile, and a CME hit 4I/ZEUS. Three separate domains, stellar, geological, and heliophysical, each producing an anomaly in the same window of time. Coincidence, almost certainly. And yet, the nova's location matters. Orion is no random constellation. It's a massive star-forming region, rich in hot young stars, neutron stars, and stellar remnants. It's a hub of cosmic violence and creation. Astronomers name this eruption V0458 Oriones. Its outburst, though small on a galactic scale, released more energy in a single day than our Sun emits in years. The expanding shell of ionized gas now travels outward, its light echo racing across space, illuminating nearby dust clouds. Could Zeus have known it was coming? That question has no scientific answer. Novae are unpredictable. They happen when they happen. But in the darker corners of late-night forums, speculation ran rampant. What if Zeus's arrival was timed to this eruption? What if it came to observe? Because the nova's photons, emitted from 1,200 light-years away, began their journey long before humans walked the Earth. Their arrival here was fixed in the cosmic schedule. Zeus's trajectory, by contrast, is recent, a newcomer, a drifter. Unless, the two are linked not by cause but by symbol. The nova drew attention. So did the quake. So did the CME. Each event a flare in its own medium. Sky, ground, sun. Each event drawing our collective gaze upward. And there, in the dark between Mars and the asteroid belt, Zeus drifted, brightening, splitting, waiting. Even the energy of a nova can teach us something about Zeus. Its light spectrum shows strong hydrogen and helium lines, but also faint traces of heavier elements, iron, magnesium, calcium, blasted outward in the flash. Such composition could serve as a cosmic fingerprint, telling us about the star's history, its companion, its fate. If Zeus were indeed an observer, it would have a front row seat to a stellar laboratory. But perhaps the connection is not literal at all. Perhaps it is psychological, a pattern our brains impose to make sense of coincidence. Humans evolved to find patterns, to link thunder to anger, comets to kings, novae to omens. In Part 5, our goal is not to claim causation. It is to lay out the timelines. September 24th, 2025, Nova Vis 0458 Orionis erupts. September 25th, 2025, magnitude 6.1 quake in Chile shakes the Nazca South America subduction zone. September 26th, 2025, CME leaves the Sun, trajectory overlapping 4I/ZEUS. 3 domains, 3 anomalies, 48 hours. Coincidence? Almost certainly. Almost. The nova will fade. Its echo will be mapped by the fictional ESA Deep Dust Mapper, stationed at Earth-Sun L2, which will photograph the reflected light on surrounding gas clouds for months. The data will help model binary evolution. It may also, inadvertently, reveal new dust lanes that Zeus's own path will intersect in December, as it passes 1.9 astronomical units from Earth. For now, the nova glows faintly in Orion, a star's heartbeat across time, and Zeus keeps moving. In part 6, we leave the sky and turn inward, to the planet beneath our feet, to the quake that rattled Chile just as Zeus reached peak brightness. Could tectonics and space be linked? Or is our pattern-seeking simply reaching deeper than science allows? The answer, as always, begins with the data. On September 25, 2025, less than a day after the nova, a magnitude 6.1 earthquake struck near Antofagasta, Chile, a region long familiar with the push and pull of tectonic forces. It wasn't the strongest quake Chile has seen, far from it, but its timing, sandwiched between a nova and a CME, striking 4I/ZEUS, gave it symbolic weight. Chile sits astride the Nazca South America plate boundary, one of the world's most active subduction zones. The Nazca Plate, an oceanic slab, plunges beneath the South American plate at about 8 centimeters per year. This slow-motion collision builds stress along faults. When the stress exceeds the rock's strength, it releases as an earthquake. In purely scientific terms, nothing about the September 25th quake was unusual. Its depth, 34 kilometers, its focal mechanism, thrust faulting, its aftershocks, moderate. The USGS issued a level 2 alert predicting no tsunami, but in the collective imagination it became part of a cosmic puzzle. Forums asked, did solar activity trigger the quake? Could gravitational tides from ZUS, tiny though they are, have influenced the stress field? Could the nova's high-energy photons arriving from Orion have any effect at all? The answer, almost certainly not. Solar storms can disrupt the ionosphere, affect radio communication, and even induce currents in power grids. But their influence on deep tectonic processes is negligible. Zeus's mass, though intriguing, is far too small and distant to shift Earth's crust, and photons from Orion are harmless by the time they reach us. Just light, spread over centuries of travel. Yet the pattern remains: sky, sun, Earth. 3 events, 1 window. And in that window, human attention was captured. That capture has consequences. When people pay attention, they discover. Amateur seismologists compared the quake's timing to regional geomagnetic indices. Space weather enthusiasts plotted CME arrival times against seismicity worldwide. Data scientists built dashboards correlating interstellar object positions with terrestrial events. Most correlations showed nothing, but a few showed noise, tantalizing hints that some hidden factor might be at play. Could Earth itself be more sensitive than we think? Could electromagnetic disturbances prime faults, lowering the threshold for rupture? Some geophysicists have proposed exactly that. Though mainstream science remains skeptical, a small body of research explores the possibility that piezoelectric effects in crustal rocks, combined with charged particles from solar storms, could create weak precursors to earthquakes. Nothing proven, nothing accepted, but intriguing enough to study. If Zeus is a mirror to our curiosity, then the quake beneath Chile was a mirror to our vulnerability. A reminder that while we look outward, Earth still moves beneath our feet. It also reminds us that patterns are double-edged. They inspire discovery. They also inspire myths. And perhaps myths have their place. They keep us watching. They keep us awake. In part 7, we'll return to the Sun, to the coronal mass ejection that left its fiery limb on September 26th and intersected Zeus's path. Was it chance or choreography? And what did Zeus do when the solar wind arrived? The sky may be silent, but sometimes silence hides the loudest answers.